Uh, Hello once again. This is lecture number 4 of chemical reactions for grade 7 science Igcse students. This is a small lecture because I'm going to talk about one particular arrangement or one particular experiment, which is a very good example of an exothermic reaction. Okay, so in this past 3 lectures, we have studied various exothermic reactions, and one of the reaction which we are going to convert it into an experiment sort of thing. Okay, and many a times it comes in the examination, this particular uh, uh, arrangement. Okay, this particular experiment, it comes in the form of a question, and that is why I want to discuss this. Okay, and it's very much in your textbook also. So let us start with lecture number 4, and this is a very common example of exothermic reaction. Now you know what are exothermic reaction by now. Exothermic reactions are reactions in which the heat energy is given out, isn't it? So hydrogen and oxygen, they combine to form water. Now you know this happens, okay, when you try to burn hydrogen in air, and in air there is always oxygen present. So when you burn hydrogen in air, okay, the hydrogen and oxygen is going to combine, and this particular reaction, this chemical reaction, this is an exothermic reaction. Okay, exothermic reaction. So what is going to happen is the heat is going to be given out, okay, plus delta H, right? So chemical energy is converted into, now when this reaction is taking place between hydrogen and oxygen, when you burn when you burn hydrogen, okay, there's a pop sound coming, a kind of small explosion also taking place when hydrogen is burning, and heat energy is given out because it's an exothermic reaction. This heat energy, okay, as I told you many a times, this heat energy can be expressed in the form of light, many a times it can be expressed in the form of sound, and here in this particular case we have made some arrangements so that we'll see that this heat energy is getting converted into kinetic energy as well. Okay, so the heat energy will be converted into kinetic energy when you burn hydrogen in this way, the way it is shown in this diagram. Can you see this arrangement? Okay, so let us try to understand this. So chemical equation will be now this one. Okay, so you can write hydrogen plus oxygen giving you water, and you will find plus delta H. Okay, that is exothermic reaction. This is a word equation, right? If you want to show it symbolically, then I will take this 4 black circles over here to indicate 4 atoms of hydrogen. These green circles I am using to show 2 atoms of oxygen, and the water formation is shown over here, that is 2 oxygen atom at the center, these green circles, and these 4 hydrogen atoms, the 4 black circles are surrounding, and there's a compact thing which is formed, and that is water. Okay, so this is symbolical way of showing a chemical reaction. I'm telling you every now and then in 7th grade, still you are not introduced to the formulas and the symbols of the elements and the chemicals. Okay, so you have to just show by these circles, right? So in the 8th grade, okay, you'll start learning these symbols of the, now suppose hydrogen, the symbol is H, oxygen, the symbol is O. Okay, so that way water, the formula is H2O. So you will be studying all these formulas from next grade onwards. So I'm not using those formulas right now for you. Now, what is this chemical reaction? It is a chemical reaction between hydrogen and oxygen taking place to form water, and this is an exothermic reaction. So heat energy is given out. Now let us try to see this diagram over here. Okay, this diagram is showing you a plastic bottle. Okay, can you see this plastic bottle? Right. Now this plastic bottle contains a stopper over here. This is a brown color stopper. Okay, this stopper has 2 wires going into it. Okay, or you can say it has a arrangement for creating a spark. Okay, so these are the 2 wires which are entering the stopper, and these 2 wires are going to create a spark inside the bottle. Inside the bottle there is already air present, okay, and hence there is oxygen present. Wherever there is air, there will be oxygen. So oxygen is present in the bottle, and we have also put some hydrogen gas in this water. Okay, so there is a mixture of hydrogen and air, or you can say hydrogen and oxygen, present in this bottle already. Only thing is, when you create a spark using these wires, okay, the reaction will be taking place. The spark will burn the hydrogen in air, okay, and when the hydrogen burns in air, the reaction, the exothermic reaction, is going to take place. And when the reaction takes place, you know, a lot of heat energy is going to be generated, and this heat energy will try to escape from the bottle. But because of this stopper, you will see that it doesn't have any place to escape. So what will happen? This heat energy, in the process of escaping out of the bottle, will push the bottle in the opposite direction. Okay, so that means the bottle will move in this direction, and this entire bottle has been tied, and it is hanging on a string. Okay, so this bottle, because of the force, okay, it will move in the opposite direction, that is this direction, towards the right. Okay, so hydrogen and oxygen will combine, and heat energy will be released. This heat energy, because it doesn't have any escape route, you know, what it will do, it will create a kinetic energy. It will get converted into kinetic energy, and this kinetic energy will result in the motion of this particular bottle, and the motion of the bottle will be in the opposite direction. Suppose heat wants to escape in this direction, okay, so the bottle will be moving in the opposite direction, this way. Okay, so this is what I want you to explain in this particular arrangement. So hydrogen and oxygen are combining together to give you water, which is an exothermic reaction. Now let me read out the arrangement. A large plastic bottle filled with hydrogen and air is attached to a string. Okay, in a room, you have to try a string first, and this bottle, which is containing a mixture of hydrogen and oxygen, that has been put on that string, is attached to the string. Now, the stopper in the bottle has wires that allow a spark to be generated. Now, through the stopper, I told you there are two wires entering the bottle. Okay, so these wires, okay, will create a spark. So wires will create a spark, and that spark is going to heat or start up the reaction between the hydrogen and the oxygen inside the bottle. So the bottle has wires that allows a spark to be generated. Once the spark is generated, the spark provides the energy to start the reaction. Start the reaction between what? Between the hydrogen and the oxygen inside the bottle. The reaction gives out a lot of energy. Now, why this energy is given out? Because it is an exothermic reaction. Okay, so hydrogen and oxygen combining being an exothermic reaction, the heat energy, lot of heat energy is given out. So heat energy is given out, okay, and the stopper is pushed out, and the heat energy is trying to push out the stopper. Okay, but the stopper is very much tight, it cannot come out. So what will happen in the process? What will happen? A force, a kinetic energy will be created, and a force will be created in the opposite direction. Okay, so the stopper will be pushed out, but the stopper will not come out. This makes the bottle to shoot along the string in the opposite direction. So this bottle will move along the string in this direction. Okay, so this is the direction in which the motion of the bottle will take place. Okay, so this entire arrangement can be asked to you in the exam as a question. Okay, they will give you all this diagram. They may tell you to label the diagram. They may ask you what is happening, and they may ask you the reasons for what observations you are going to see and all that. Okay, so it can create a beautiful question in short. Okay, so that's the reason I wanted to make a separate video on this particular topic, that is exothermic reaction taking place between hydrogen and oxygen when it is ignited using a spark. Okay, and this is where the heat energy which is given out in the reaction is converted into kinetic energy, which makes the bottle move. Okay, So that's all for this lecture number 4. In the next lecture, lecture number 5, I'll be continuing with endothermic reactions. Okay, bye.